if we put in, so alpha tocopherol would have methyls here, here, and here. So in here we have an oxygen. We've got some carbon-carbon double bonds, and then over here we're going to have methyls, which means that a lot of these double bonds are relatively situated next to something else that will confer more stability. A ring, so a ring structure is inherently considered really stable because they can share those electrons in the ring. An H is easier to pop off than a CH3. So the more methyls that you have attached relative to a hydrogen, to a ring structure, it's harder to break that carbon-carbon bond than it is to take an H. It's really hard to break an H as it is, but it's even harder to break a CCH. Okay, let's see, there's one other bit thing. Here we go. Here's the last one. Okay, so this is on, sorry, or make it upside down, but I think upside down is not practical. So this is on page 676. So this shows you how you go from alpha to, oh, not practical. I'm going to flip it upside down. This is like tiny. Okay. The molecule's the same, it's just everything's written upside down. All right. So this is alpha tocopherol. This is the alpha tocopherol radical. Okay? So again, here's the OH, and then there's an oxygen. So when you add your ROO, you create an oxygen double bond, which is 8A peroxy alpha tocopherol. And then you can make an ROOH, and then you break this extra little bond right there. You donate that H, and then this is double bonded and it's broken. I don't want you to memorize this structure. I think it's more complicated than the sorbitol radical, because in order to go, once you go backwards, then you have to put the H back in, and there's a complex mechanism. But if you notice, we usually stop here. This can go, this is an extra pathway where you tend to be more degraded. But if you look here, this is just 3 steps. Alpha tocopherol radical, and there's our combination with the ROO, right? Then we get a double bonded O. So you can reverse this fairly easily by breaking that double bonded oxygen and going back to the OH, which gives it the ability to absorb an extra electron again, which means you can use that energy from absorbate, taking the sorbitol radical and going back into it.